because some of these don't factor quite the way they're supposed to. But the reason we're going to focus on these today is because these are those higher order quadratics that we've got to work with, okay? So what we're going to do is we're just going to kind of go down the odd column. I don't have time to work every single problem, but you'll kind of get the idea of how these work. So, golden rule of factoring, or solving by factoring, you are going to set the problem equal to 0. You are going to factor completely, starting with checking for a greatest common factor and then doing one of the other factoring techniques after that. And then you're going to set each factor equal to 0. Now, for quadratic equations, you can solve them by using the square root property, complete the square, quadratic formula, and we are going to have to incorporate some of that in here. So you're going to have irrational answers. You're going to have imaginary complex answers. So on this, we get what we get, okay? So in number 1, I call it a higher order because it's bigger than a square. It's set to 0, so we don't have to worry about that. But do you see a greatest common factor in there? So I'm going to take out the x, and that leaves me with x squared plus 1. Now, I cannot factor x squared plus 1. If that were x squared minus 1, I could factor it, okay? So once I get to this point, I'm going to set the factors equal to 0. X is a factor, and then x squared plus 1 equals to 0. So 0 is one of my answers. Now, back up here, it says for each quadratic equation, you can solve by the square root property if it applies. And remember, the square root property is just ax squared plus c equals to 0. We can do the complete the square process. My personal preference is quadratic formula because I don't have to worry about b divided by 2 and square it and do all that stuff with it. To me, quadratic formula is the easier option. But here, I can apply the square root property, which means I'm going to subtract 1 from both sides, and then I'm going to take the square root of it. Well, that gives me plus minus I, because if you recall, the square root of -1 is an I. Do y'all agree? Okay, so I have an exponent of 3, and I was able to get 3 answers: 0, positive I, and negative I. Now, I caution you here because there are going to be 2 types of directions. It's going to say real solutions, which in this case would just be 0. That's the only real number in our set, correct? And then it will say all solutions. And that would be the 0 and the plus minus I. All solution legitimately means all solutions. But if it says, and you've got to read your directions in Math Excel very carefully, because if it says the real numbers and you type in I and negative I, it will mark it wrong. Then you'll get frustrated because you'll say, well, I know I did it right, and I know those are the answers, but you've got to be very careful. Do they want the imaginaries or just the reals? Okay. Now, number 3, it's a higher order quadratic, or it's a higher order polynomial because of the x to the 4th, the power. All right. This is actually a difference of squares. In order to be a difference of squares, it has to be 2 terms. We've got x squared negative 64. There is no common factor, so we checked that. It's set equal to 0. So I've got a perfect square here. As long as my exponent is even, it's a square. 64 is a square. So I'm going to split x to the 4th halfway, 2 and 2. If that were 6, that would be an x to the 3rd and x to the 3rd. As long as your exponent is even, you can split it evenly, okay? So I've got minus 8 and positive 8. This is a difference of squares. Don't you take 8, square it, you get 64. Now, I'm going to take my first factor, x squared minus 8, set it equal to 0. X squared plus 8, set it equal to 0. And I'm going to apply the square root property because I now have ax squared plus c. So I'm going to add 8. I'm going to take the square root of that. And I get 2 square roots of 2. Now, if you remember, when you take 8, the perfect square is 4. The non-perfect square is 2. And that becomes 2 square roots of 2. So when you break down the square root of 8, or any square root, you always have to make sure that you pull out all the perfect squares first. All right. So when we go to solve the second set of factors, we get x squared equals to negative 8, square root property. So x squared, or x, equals to plus minus. What's the difference between the square root of 8 and the square root of negative 8? Negative 8 is an imaginary number. So I take the imaginary unit out. I'm not going to break down 8 again because I just did it in the previous example, right? So this would be 2i square roots of 2. If you want to write it as 2 square roots of 2 with the I on the back end, just make sure that you do not put that I under the radical. It is totally separate. So which way would you rather see it? With the I in front of the radical or behind? It does not matter to me. What'd you say? In front? Okay. So I have 2 real, 2 imaginary, grand total of 4. So the exponent dictates how many answers, real, imaginary, all added together, that you should get. So we have 2 answers here, 2 answers here, grand total of 4 answers. Okay. Now, is this your number 5 on the back side of that worksheet? Now, these are the cubes that we did. And number 5 and number 7 are both cubes. Number 5 is the sum of cubes, which equals to a plus b, binomial, and a squared minus ab plus b squared, trinomial. The problem with this trinomial, you will never get it to factor. The good thing about factoring and trying to solve a cubed equation is you know what you get. You get a binomial, which gives you a real number every time. And then this one, you are going to have to do the quadratic formula for. You don't have an option. Well, your other option would be complete the square, but I prefer not to do complete the square. Most students are more successful with the quadratic formula. So when you factor a cube, you get the same outcome every time. Who can tell me the cube value for 125? Is it 2 to the third, 3 to the third, 4 to the third, 5 to the third, 6 to the third? You have a list in your notes. You can flip back through your packet and find that page where we did the cubes. Five to the third. Now, remember, we wrote both values as a cube, and then we scribbled out the cubes, and that gave you the binomial, which is this part, and then we used those 2 values to get the trinomial. Take the first value in the group and square it, so that gives me x squared. Multiply these 2 together, that gives me minus 5x. The signs are set in stone. Those 3 signs never change. And then you're going to take the last number and square it. So 5 squared is 25. right? So when I set my binomial equal to 0, x plus 5 equals 0, so x equals -5. You will get a real number there every time. It could be 1/2, it could be -6. I don't know what it's going to be. It's just whatever that factor is, but that one will give you a real number, plus, minus, decimal fraction, whatever it is. This is the one that we're going to have to do the quadratic formula for. So my a value is 1, my b value is -5, and my c value is 25. There are no factors of 25 that add up to 5. There are none. You got 1 and 25, 5 and 5. And no way you pair those, you're going to get 5. This trinomial, when you're factoring a cube, never factors. So I don't ever have to worry about it. If you don't ever want to factor another quadratic, don't. Do the quadratic formula. Okay? So just in case you forgot, x equals -b plus minus square root b squared minus 4ac. And all of that is over 2a. So I'm going to take these three numbers, plug it in, and I'm either going to get a real outcome, like a square root of a positive number, or I'm going to get a square root of a negative number. And that's okay. What you get is what you get. Just be very careful. So I'm going to go in and fill in all my parentheses, and then I will come back and grab my numbers. Creature of habit. So I'm taking all A, B, and C's out, and I'm going to replace them with these three numbers. So I've got -5, -5. Then I have A, and C. Double negatives, denominator. And if you recall, we spent more time on the square root than we did checking for double negatives and multiplying out the denominator. All right, so I need the number that ends up under that radical. I will tell you that it's going to be negative. So when you do all this math right here, -5 squared minus 4 times 1 times 25. So all this math, what negative number do you come up with? -75. That means my answer to this quadratic is going to be imaginary. Is it okay to have imaginary answers? Absolutely. So now what I have to do is I've got to do I square roots of 75, and I have to break down the square root of 75. What's the perfect square factor of 75? Yep, 25 and 3. So that gives me 5i square roots of 3, because 25 becomes 5. So I get x equals 5 plus minus 5i square roots of 2. All of that is over 2. Now, the very last thing that you always look for, and it's not going to give me a hello. This number, I don't care if it has an I or not, and this number, can you reduce all three of them? Then you do not reduce this problem at all. Okay? It's all three numbers or none of them. So I have three answers, and that's what I was looking for. This one, and then these two imaginary. This one is real. These are imaginary. So pay attention to your directions. If your directions said, give me the real numbers, all you would type in was -5. If it said all solutions, you give them both. All right. So number 7, just to have another cube, and I will remind you, this is a difference of cubes. So this is the a cube minus b cube that we talked about last week. So your binomial is a minus b because you're doing the difference. Then you're going to have a squared plus ab plus b squared. Those signs are not negotiable. If this is a minus, the first one's a minus, then plus plus. So the patterns are very similar, except the signs in the quadratic change a little bit. So I have no common factor. It's set to 0. And what is the cube factor of 216? It's in your list. It's in your packet. We talked about it last week. 6 to the third. Okay, so that means if I scribble out both of those 3's, my binomial is x minus 6. And then I'm going to use those numbers to fill in the gaps. Now, I know for a fact it's going to be plus plus because that is the formula for factoring the difference of cubes. First one, square it. Multiply these two together, you get 6x. And then square the last one. 6 times 6 is 36. We're going after 3 answers. The first one comes from x minus 6 equals to 0. So this is one of my answers from the binomial. I've got to do my quadratic formula again. So A is 1, B is 6, C is 36, and that's going to give me my last 2 answers. Every time you do the quadratic formula, it produces 2 answers. Whether they're real or not depends on what the radical is. So x equals, and put all my parentheses in, because I wrote the formula for you in the previous example. So B goes in first, A, and then C goes in last. Check for double negatives. Multiply out your denominator. That's the easy part. And then the rest of your time is going to be spent on that radical. Negative 108. Okay, so I get I square roots of 108. What is a perfect square factor of 108? I'm not going to tell you.
36.
All right, 36 and 3. So that becomes 6i square roots of 3. The square root of 36 becomes 6. So I have negative 6 plus minus 6i square roots of 3 all over 2. This one can reduce because all 3 of these numbers can reduce by dividing by 2. Do y'all agree? So negative 3 plus 3i, leave the radical alone, and that would become a 1. You do not have to show a denominator of 1. So that becomes -3, this becomes +3, and that becomes 1. Denominators of 1 can be dropped off. All right. The last one of these that we're going to do, and then we're going to kind of shift gears and do some division. This is a higher order quadratic. I have x to the 4th, which means I'm looking for 4 answers total. Whether they're real, imaginary, does not matter. But this is a trinomial, so I'm actually going to be able to factor it. I can think of it as x squared plus x minus 42. This number is half of this one. This number is half of this one. So my mindset has to work this way, okay? So what I'm going to do is I'm going to take that exponent and I'm going to split it x squared, x squared. This middle number has to match those x squares. If this were an x to the 3rd, you cannot do it. So it has to match up. 4, half of 4 is 2, and then the constant number. 1 plus, 1 minus. This number is negative, so that always produces a plus or minus. What are factors of -42 that add up to 1? They have to multiply to -42. Okay. 7 and 6. Which one's going to be negative? I need a positive 1. So which one of these needs to be negative? 7 times -6 is -42. And 7 plus -6 is +1. So there's your C value and there's your B value. So I'm going to put the 7 with the plus and then 6 with the negative. Now, I have 2 quadratics that I'm going to set equal to 0. And I'm going to use the square root property. So I'm going to subtract 7. Take the square root of both sides. And that gives me plus minus I square roots of 7. Since it's square root -7, you can't break down the square root of 7. For the second one, I get x squared equals to 6. Take the square root of that. You cannot break down the square root of 6. It is a real number, so there is no imaginary unit because 6 is positive. So do we have 4 answers? 2 imaginary, 2 real. So the exponent, the degree, the highest power in your problem dictates how many answers you have to find. Do you think some of your answers could ever repeat? Do you think you might have a situation where you have a number that repeats? You can. Okay, as long as you can account for all answers. Any questions? Do y'all see anything else on that page or either the front side of the page that you want to see before I move to the next topic? Anything? All right, so I don't know if that's the lunch cart. Kevin, do you want to look and see where the lunch cart is? Okay. We will pause here. I am actually going to put the 0 in my list of numbers. So that's going to be 1, 0, -17, and 32. I'm going to draw my line and do the same multiply, add until I run out of things to multiply and add. So bring down the first number. Then we're going to multiply. Then we will add. Then we'll multiply -5 times -5, which gives me 25, and I will add. All right, do y'all agree with that? Now, in the original problem, the biggest exponent was k to the third. So this is 1k squared minus 5k plus 8 minus, and the only reason I'm putting minus is because that's a negative, and then 8 over k plus 5, what you were dividing by. Any questions about that one? All right. Now, the last one on this page, it's under the missing powers example. So what power is missing? The x squared is missing this time. Do y'all agree? Okay. So technically, this is 8x to the fourth minus 64x to the third. I always just put plus 0 because it's just easier. So now every exponent is accounted for. 4, 3, 2, 1, none. So what number are we dividing by? 8 or negative 8? 8. Then I have 8, negative 64, 0, 3, and negative 28. Leave yourself some space and start the process. First number always comes down as is. Eight times 8 is 64. What happens when you add those numbers? It gives you 0. Now, 8 times 0 is 0, not 8. I get a lot of mistakes right there. 8 times 0 is 0. Anything times 0. When you add those zeros, you get 0. 8 times 0 is 0. 3 plus 0 is 3. And 8 times 3 is 24. And when you add, you get negative 4. So technically, what your answer is 8x to the third, because our biggest exponent to start with was a fourth, plus 0x squared plus 0x plus 3 with a remainder of negative 4 over x minus 8. If you type in those two zero terms, Math Excel is going to mark it wrong. Because what happens to those two zero terms? They cancel out. They go away. So your final answer is technically 8x to the third plus 3 with that remainder, negative 4 over x minus 8. That is how your answer should look. So we had a missing term and we ended up with some missing terms, and that is okay. Everybody okay with that? All right. So now there's one thing that's not in this packet, and I don't know why I left it off. Okay. But I'm going to give you a couple of examples. This is called the remainder theorem, and I apologize for having to write in this space, but you can probably get it over here in the margin. Now, I'm not going to tell you that you cannot do this the way you have always been taught. Goodness gracious, I'm sorry it's taken so long. I wish it would let me make the eraser bigger. All right, so if I give you this function, f of x equals to x to the third plus 2x squared minus 22x minus 45, and then I ask you to find f of negative 5. What would you do? I would plug negative 5 in for every single x. Do y'all agree? All right, you do that. Because I'm going to do it a different way, but I want you to do it. All right. Hopefully you have your answer. Did you get negative 10? Anybody get negative 10? Okay. Did you do it the way I did it? Or did you plug negative 5 in for every x? Okay. What happens is I don't like plugging in negative numbers. So what I did is I just divided by the negative number that was there. Okay. My outcome, my remainder, this is why it's called the remainder theorem. The remainder is the value of the problem when you plug in that number right there. Same thing. Does that kind of make sense? Okay. So you do have a couple of these problems in your homework because I just looked in your long division and synthetic division. It does not specify if you use long division or synthetic. I would assume most of you will use synthetic because I think it's easier. But you do have a couple of these problems. You can use synthetic division and the remainder is always the answer, or you can do old school and plug negative 5 in to the problem and out comes negative 10. Your call. Does not matter to me which one you do. But if they ask you for the remainder theorem, this is technically what they're asking you for, but just plug and chug or do this method, whichever one you want. Okay? All right. Now,